So please make sure your PMOS width is twice the width of the NMOS. All of you guys have done ELDO simulations. CR file done? Check. Okay. Export. Export सेव कर दिया उसको फाइल वो तो भैया ने सेव कर दिया बता दो क्या करूँ. Now we have made the circuit in the cadence virtuoso spectre. Now we have to export the circuit for the ELDO simulations, and the format will be src.net.
We are basically exporting the netlist of the inverter,
so that your ELDO simulation knows what is the PMOS instance and what is the NMOS instance, and it will supply the input stimuli across it, and you can capture the output from it. So after this, you have to save your circuit using this one. Save it, then come to Virtuoso. Go to File, Export, CDL, and click on the CDL option. Now you have to choose your folders where. All of you guys are at the same step. Did you guys save? Save the circuit. Now go to the Virtuoso command prompt, CMD, Virtuoso CMD. Okay, comfortable? Now file, there's an option export in the file. You have to click on it and select the CDL option. A window should pop like this. Is everyone comfortable till here? Now you have to choose a library name which you would have created at the instance of the cadence spectre. Your name, your schematic. Okay. Now you have to give your name here in the output CDL netlist file, and your name should be of extension .src.net, like please make sure your extension is that only, src.net. हाँ मतलब तो डॉट रहेगा तो उसी को वही करेंगे. हाँ ये बताने की जरूरत है. And please make sure your run directory contains a full stop or dot, because it will save in the current directory only. Everyone comfortable till here? Now you click OK. You don't need to make video. We are forming it. We will create OK. See, the command line says the CDL is in progress and the CDL creation has succeeded. Done till here? Which step? After that, your run directory should contain a full stop. See, I will explain again. Go on File, click Export, go to the CDL option. Okay. Now your top cell name is that the one which you are making in the expector. Now your output CDL netlist name. Please guys, listen to this, otherwise you will face difficulty in running the ELDO simulations. The extension should be src.net. Your name can be anything. Your extension should be src.net. And please make sure your run directory is dot, because it signifies that you are saving in the current directory only. Like I have saved like this too. And when you click OK, the command line says the CDL out is running in the background and the CDL out is in CDL out translation is in progress. If the command is successful, you will get a pop-up like this. The job has succeeded. You cannot proceed further if this says the job has failed. फेल हो गया भैया एक बार देख succeeded बाकी कॉल should I should I explain once again क्या
सीरियल रन कर तो दोबारा रन कर सकते हो, इसको रख सकता हूँ।
लाइब्रेरी ब्राउजर के दिन में जाओ और वहाँ जहाँ तुम्हारा स्कीमेटिक बना था ना वो वाली लाइब्रेरी सेलेक्ट कर लो क्योंकि उसका स्कीमेटिक देगा हो गया क्या सबका यहाँ तक So please open this src.net. It should look like this. देखो इसको पढ़ना सिखा देता हूं मैं कैसे पढ़ते हैं इसको ये सब तुम्हारे कॉन्स्टेंट्स सर्किट्स कॉन्स्टेंट्स हैं इसमें कुछ नहीं करना हम लोगों को ठीक है your library name is mentioned here in front of the library name cell name what you have given would be mentioned here in front of the cell name and view since you have exported the schematic so the view is named schematic view mode is schematic only now this is sub circuit it means it is showing the part of the circuit which you are naming your circuit is named inverter so the sub circuit command shows inverter in front of it ठीक है now these are the 4 pins ground input output VDD these are 2 pins and it implies the stimuli we are giving see ठीक है मतलब it is 4 pins and it will imply the stimuli we are giving in the sense if you remember in your schematic there are 4 pins input output VDD and ground it is mentioned here in front of your circuit name after that the pin info input in pin is input type therefore it says in in colon I same for the VDD same for the ground is basically bipolar type but you can also give it input type it doesn't matter and output is O type it means output type out is O type समझ में आ रहा है ना now it says mm0 if you remember and you can check in your spectre the device says mm if you go to the spectre I'll show you this device is named mm see m0 so the src has created an instance called mm0 and this is a pmos m0 is a pmos see m0 and it mentions psvtlp it means pmos after m0 instance name you have to mention your pins that you will provide it is output input VDD and ground same pins that we have mentioned here order may be different but the pin names are same then the instance name is it pmos or nmos that is given psvtlp then w 0.27 which we have given here see the w that we have mentioned here is in the src.net after that length since we are working in 65 nanometer, the length is 0.06. You can also cross check from here the length you are giving. You don't have to worry with these all parameters, sense, n, con, m. You don't have to worry about this for the assignment one. In the due time, we will tell you what each command, each line means. See, there is also a parameter called nfing. Basically, it's a parameter of number of fingers. It's a concept sir will teach you in class. After that, we can show you what does it mean. But for now, time being, it is 1. Same for mm1. Now, can you please check what we are doing is correct? The instance is m1, and in SRC it meant mm1. Same flow. Since it is an NMOS, we have NSVT-LP. See, there will be 2 instances. NSVT-LP means that the NMOS you are instantiating is of low threshold voltage. LP means low power. Comfortable till here. And dot ends mean the CR file ends here. The circuit instances parameters are all informed to the CR file. ये यहाँ तक आ जाओ सारे एक बार. Then we can proceed further. एक्सपोर्ट तो सबका हो गया ना. कोई है जिसका एक्सपोर्ट नहीं हुआ. कमांड पढ़नी आ गई, मतलब सीआर एसआरसी फाइल पढ़नी आ गई. सी अगर कोई टेम्पर करके छेड़ेगा इसको और असाइनमेंट में आगे पीछे सबमिट करेगा तो ये टाइम स्टैम्प है, हम ये भी चेक कर सकते हैं. तो कोई फायदा होगा नहीं क्योंकि उसी टाइम जनरेट होगी ये.
कमांड अभी क्या लगा है?
See, after this, what we have to do, we have to write a CIR file for the ELDO simulation because ELDO takes the input as CIR file. CIR file is nothing but set of instructions that your ELDO simulation will perform. Okay? For the CIR file, what we will be doing? The exported src.net file is given as an input to the CIR file, and we will give stimuli inputs to the CIR file. Specify the input stimuli to the CIR file. It will take your instance, apply your input stimuli, and it will generate a waveform, output waveform in WDB format. And we can use Synopsys as a WDB exporter to export that waveform and see if our functionality is matched or not. So this is a sample CIR file for the inverter. बता देता हूँ लिखते कैसे हैं. पहले बेसिकली समझ लेते हैं हो क्या रहा है इसके अंदर. What is happening we should understand first. See, the first line is dot include model file name 65 nanometer. This is by default. You don't have to do anything in this. You have to just copy paste this line only. Okay? Now there are corners across which we will test our device. For this explanation, we are using slow corner. So that's why it is mentioned min p, min s, min n dot cir. Okay? In your ELDO folder, there will be a subfolder known as there will be a folder known as model file underscore 65 nanometer. You can see there are some folder corners and you can see all the corners there. Basically this is default. Until and unless we state, please don't change this. Now if you remember your file name, the file we have imported from src.net, that file name is given here. Since mine was exported as inv.src.net, I have to include inv.src.net. The file name should be exact, otherwise it will give error. So please, यहाँ तक किसी को कोई दिक्कत है, and dot includes means you're including the files. Dot include का मतलब ये है. So your generated src file name should be given as an input to this. Dot include src dot मतलब dot include file name dot src dot net. ठीक है. भैया is everyone comfortable till here? सिर्फ फोल्डर में आ गया सबका, उसका देख ले. प्लीज एक बार देख लो, बिकॉज ये स्टेप दोबारा रिपीट कर दूंगा. प्लीज फोकस प्लीज हियर, फोकस प्लीज हियर. आफ्टर दिस यू एक बार गाइस प्लीज देख लो यहाँ पे, ये स्टेप बहुत क्रूशियल है. ये नहीं हुआ तो फिर सेम फोल्डर में होने के बाद भी नहीं चलेगा. प्लीज फोकस हियर. आफ्टर वी हैव इंक्लूडेड आवर src.net, बता अभी आई एम एक्सप्लेनिंग, देन वी विल गिव देम CIR. एक बार समझ लो CIR फाइल, क्योंकि एक असाइनमेंट की हम दे सकते हैं, उसके बाद तुम्हें खुद ही लिखनी पड़ेगी CIR फाइल. यहाँ के बाद डॉट इंक्लूड src.net के बाद व्हाट वी आर डूइंग, वी आर सेइंग दैट दिस फाइल कंटेन्स एन इंस्टेंस ऑफ दिस. x1 इंस्टेंस कंटेन करता है ये. दिस मींस दैट ओनली, क्योंकि तुम्हारी फाइल यहाँ पे आ गई है, तो योर सिमुलेटर नोस कि अब उसके अंदर इंस्टेंसेस हैं. So not what now what we are doing is we are saying our instance is named x1, but if you remember in the src.net there was nothing called x1, not था हमारे पास. So आप उसको रिजॉल्व करना है. वो कैसे करेंगे बताता हूँ, लेकिन यहाँ पे हम इंस्टेंस कुछ देंगे. some name will be there. ठीक है. then again पिन्स का ऑर्डर अगर तुम्हें याद होगा तो src.net में जो ऑर्डर था वही पिन का ऑर्डर कॉपी करा गया यहाँ पे. So what you can do to avoid errors is that इस वाली लाइन को पूरा कॉपी कर लेना. प्लीज कॉपी दिस लाइन एंड पुट इट इन योर CIR फाइल एज इट इज. बताता हूँ. डॉट इंक्लूड src.net के बाद हमें करना क्या है कि हम अब उसका नेम करेंगे. हमारा जो सिमुलेटर है उसको बताएंगे कि हमने जो उसके अंदर फाइल्स इंक्लूड करी है उसमें इंस्टेंसेस का क्या नेम है. तो ये अगला स्टेप वही कर रहा है. ठीक है. x1 जो है एक मान लो पैरामीटर का एक ब्लैक बॉक्स टाइप का मान लो. अभी x1 इज उसका नेम है. ठीक है. उसके बाद हम कर क्या रहे हैं, यहाँ पे पिन स्पेसिफाई कर रहे हैं. और पिन्स का ऑर्डर कैसे देख रहे हैं, क्योंकि अभी तो 4 पिन्स है तो तुम हाथ से लिख सकते हो, लेकिन जब कॉम्प्लिकेटेड डिजाइन होते हैं तो पिन्स के नाम और ऑर्डर याद करना पॉसिबल नहीं है. तो तुम्हें करना क्या है, तुम्हें अपनी जो src.net फाइल है वहां जाना है, ये पिन्स के नाम वहां से कॉपी करने हैं. ठीक है. तुम पिन्स के नाम कॉपी कर लेना, वहां से पूरा कॉपी करना, सब सर्किट के बाद एंड तक सब कुछ कॉपी कर लेना. एंड अगली बार इंग्लिश में, अभी इसको बोल के इंग्लिश में बोल देता हूँ. जो कॉपी कर लिया था तुमने, उसके बाद इसको x1 के बाद पेस्ट कर देना. ठीक है. इसमें एक दिक्कत तुम्हें आएगी कि इन्वर्टर का नाम src के अंदर पहले था, इसके अंदर बाद में लिखा हुआ है. फिर उसको भी एज इट इज कॉपी करना और बाद में पेस्ट कर देना. ये करोगे तो एरर नहीं आएगा कॉम्प्लिकेटेड डिजाइन में, इसमें डिबग करने में, वरना बहुत दिक्कत होती है कि एरर कहाँ आ गया है, क्योंकि ये केस सेंसिटिव है. हल्का सा भी कुछ आगे पीछे हुआ एरर थ्रो कर देगा कि इंस्टेंस नॉट फाउंड. ठीक है, बता। See, after exporting the src.net, what we are doing is we are writing a CIR file, and we are telling the CIR file कि we have exported the src.net. Now we are creating an instance from the src.net. So what we are doing is, in the same directory as the src.net, we have to write the CIR file. So after including this src.net, what we are saying to the simulator is that there is an src.net file, and we want to create an instance of x1 from the src.net. This x1 signifies that the name of the instance. After this, you have to give the pins name to the simulator, and the pins name should be in order in which you have instantiated in the src.net. So to avoid confusion, what we are doing is we go to the src.net, we copy the pins and the instance name from here, like inverter, ground, VDD, in and out. मतलब the order जो मैं बोल रहा हूँ, and the order is there. You have to copy this order only and paste it here. The problem you will face is the inverter name is in front of the src.net, but here the instance name is at the back. So what you do, you cut this inverter name from the front and paste it in the back. Please पहले यहाँ तक कर लो. Please proceed. ये समझ में आ गया ना सबको ठीक करके आ रहे हैं? Because for the simple designs it is very easy to remember the names and the order, but for the complex designs where you will be having 32 pins, 64 pins, it is very complicated. And this is a case sensitive. This is case sensitive, so a single mistake will cause the simulator to fail, and it will show an error that instance not found.
Last one.
भैया see, I have copied the contents. Now I will make a folder here. That is a text document. Paste the contents here, save it, rename it, whatever you want. Send it to your Google or Gmail, mail it to yourself. Log into your virtual machine, download this file, and change the extension to .cir. And then copy paste it into your current directory in which you have exported the src.net. It will work there only. But please remember कि ऊपर 4 स्पेसिस हो. ये सिमुलेशन यहाँ पे मत चिपका देना, एरर आ जाएगा. हाँ, प्लीज ये ध्यान रखना कि सिमुलेशन एकदम स्टार्टिंग से स्टार्ट ना हो, एरर थ्रो कर देगा एल्डो. एटलीस्ट 3 स्पेसेस छोड़ देना, 3 एंटर मार देना. Is everyone clear till this step? हाँ ठीक है, ये करते रहो. तब तक मैं एक बार समझा देता हूँ कि CIR में करा क्या हमने. और किस्मत अच्छी है भाई, नहीं चलता ऐसे. See, first एक बार please try to understand what I am trying to say, and then you can do your folder desktop folder खेल लेना बाद में उसके बाद. After this, what we are saying is we are specifying the environment variables. Okay, so environment variables are stated as dot PARM, parameter. Short form for that is param. After param, what we are saying is supply voltage are fixed. Supply voltage is 1.08 volt. Volt लगाने की जरूरत नहीं है. You don't have to put volts. It will understand you are doing it in volts. After supply, what we are stating is we are telling the simulator when to end the simulation. So dot param t end. It means it will stop after 150 nanoseconds of simulation time. ठीक, ये छोड़ो अभी, अगला वाला कमेंट है. And now we have to specify the temperature. Because since this is spice simulation, temperature will have a very adverse effect on the simulation results. After this is completely optional. This means that we are giving a load capacitance, because since we are driving a circuit cannot be driven if it is loadless or there is no load to drive the circuit. So this means only we are driving the load capacitance. You can copy it as it is. Don't need to change it. Now we will supply the input stimuli to our instance that we have created from src.net. This is the signal name. The first name is the signal name. Okay? This VD means signal name, and what it means is, this means pin name where this signal will be supplied. This is the pin name. This is the signal name, and this is the pin name where the signal will be supplied. Okay? After this, the low value of your signal 0 and the high value of your signal. This is a parameter, and we took the parameter as 1.08. So it will generate a voltage at the VDD pin, which will be low of 0 and high of 1.08 volts. Okay? Same now for the ground. VG is the signal name, G and D is the pin name that we have given, and 0 is the low value, and 0 again is the high value also. So this means this is a complete flat signal, flat profile of the signal. Understood till here, Aditya? See, the pin name that you are giving here should be same as that you have given here, the input pins. ठीक है, इनको ऑर्डर मैटर नहीं करता, तुम इनपुट स्टिमुलाई कैसे दे रहे हो. इसके बाद योर सर्किट का कोई ऑर्डर मैटर नहीं करता, यहां तक ऑर्डर सेम रहना चाहिए पिंस का. उसके बाद हाउ यू गिव इनपुट स्टिमुला, हाउ यू टेक आउटपुट स्टिमुला, इट डजंट केयर. अंडरस्टूड टिल हियर? अगेन बता फिर से. दिस इज द सिग्नल नेम, प्लीज. दिस इज द सिग्नल नेम. This is the pin name on which you will apply that particular signal. After stating the pin name on which you are applying the signal, you have to specify the values you are applying to that pin. The low value comes first. So the low will be 0 and the high will be supply. Supply here means 1.08 because we have declared it as a parameter. So if we write supply anywhere in the CIR file, it will interpret as 1.08. Same for the ground pin. VG is the signal name. GND is the pin name. You can see it from here. GND is the pin name. And this is the low voltage and high voltage. Both are 0. It means that signal profile is completely flat. अरे कुछ भी दे सकते हो इसको, तुम अपना नाम भी दे सकते हो, उसको फर्क नहीं पड़ता. It only means that when the simulator will run and the waveform it will show, it will contain that name on the top. ठीक है? See, what we have given here is VDD and ground only. We have not yet given input stimuli to the inverter. We have only initiated the VDD and ground. For inverter to work and to see it functioning, we have to give input stimuli to the inverter. See signal name. This is an important step. Please, ये ऐसे स्टिमुला दोगे आगे भी तुम उसके अंदर डीवीडी एमडीटी के अंदर. So please focus. ये सिग्नल नेम है. ये इनपुट पिन. This is the input pin on which we are giving. See low value, ground. Okay, 0 volts, that is low value will be ground. And now at the high value, what we are doing is we are defining a pulse train we are defining here. Pulse train की definition ऐसी है. See, after defining the pulse, what you are saying, this means low voltage of the pulse. This means high voltage of the pulse. This is starting delay. This is rise time. This is fall time. This is pulse width. If you don't specify any pulse width, it will take 50% as by default. And this is time period of your pulse. Order should be same. Order should be same. Values can be random of your choice. what you want to see in the output waveform. Is this pulse train clear? Abhi, for the assignments and for the time being, start with pulse only. क्या ये फॉर्मेट है एल्डो का, एल्डो की मैनुअल में फॉर्मेट दे रखा है, हम उसको दे रहे हैं, मतलब एक फंक्शन है पल्स, उसके पैरामीटर ऐसे देने हैं, हाई से ऑर्डर मिलेगा। यहां तक क्लियर है सारे, या दोबारा बताऊं वोल्टेज कैसे दे रखे हैं हमने? सो हो क्या रहा है, पीमॉस को वीडीडी दे चुके हैं, एनमॉस को ग्राउंड कनेक्शन दे चुके हैं, जो कॉमन टर्मिनल था वी आर अप्लाइंग द पल्स ट्रेन देयर, ठीक है। सो व्हाट यू एक्सपेक्ट इज फॉर द हाई वैल्यू यू शुड सी अ लो वैल्यू बिकॉज इट इज एन इन्वर्टर, एंड फॉर द लो वैल्यू यू शुड सी correspondingly हाई वैल्यू, एंड वी विल सी दिस स्पेक्टर में देखा होगा, we will try to replicate the result in ELDO simulations also, EZ wave, we will try to replicate in the EZ wave also. Now you have given the input stimuli and now you have to probe the outputs. What does probe mean here? Probe means that you have to see the output waveform. So how will you see the output waveform and how will the tool know? What you are saying to this saying to the tool through this line means that for the instance x1 probe the voltages. V means voltage here, V means voltage here, asterisk means all the instances of that x1 instance. You can probe all the probe all x1 instances for the voltages. Probe only means plotting. Probe only means plotting. If you don't write this command, the simulation will get run, but the graph will not be plotted. See, after supplying the input stimuli, what we have to do, we have to see the output waveform. Output waveform we have to see. For that waveform, we have to tell the simulator that we want to see the output waveform of that input stimuli that we are applying. If we don't tell, what the simulator will do, it will apply the input stimuli and it will generate the results, but it will not plot the waveform of it. So these two commands is instructing the ELDO simulator to plot the waveform for your instance. See, we are supplying the we are saying to probe the voltages and we are saying to probe the current also for this instance. V means volts here, small v means volts, I means current. एस्ट्रिक्स में ये एस्ट्रिक्स का मतलब कमेंट है, ये कमेंट है। Asterisk means that you are probing all the instances of this module that you have defined in subcircuit. That is src.net में जो डिफाइन करा है सबको प्रोब करेगा वो।
अटेंशन एवरीवन, सब लोग इधर देखेंगे, दोबारा नहीं बताऊंगा क्योंकि सबको प्रॉब्लम हो रही है वाला, ठीक है। तो बहुत सारे लोगों को कॉर्नर फाइल नहीं मिल रहा है, ठीक है। तो कॉर्नर फाइल किधर है मैं दिखा रहा हूँ, उसको जस्ट कॉपी पेस्ट करना है तुम्हारे CMOS 65 फोल्डर में। ये तुमने यहाँ अदर लोकेशन का ऑप्शन आया, ठीक है, उसमें कंप्यूटर को ओपन कर लो, वहां पर ग्लोबल फोल्डर मिलेगा, इसमें एक कॉर्नर फाइल है, इसको जस्ट कॉपी करना है और CMOS 65 में पेस्ट करना है, ठीक है। कोई दोबारा नहीं पूछेगा, ठीक है। क्या ये देखो यहीं से दिख रहा है ना तुमको, ये यहाँ पर जाओगे तो अदर लोकेशंस करके आता है, उसमें ग्लोबल फोल्डर में ये कॉर्नर फाइल मिलता है, तो वहां से इसको कॉपी करके CMOS 65 में पेस्ट कर देना, तो कॉर्नर फाइल मिल जाएगा। इसके अंदर ये देखो सारे कॉर्नर्स हैं, ठीक। यू गॉट इट, यू अंडरस्टूड, you I'm saying many of you are not getting corner files, you know. So I was telling where to get. You got it, or I have to tell one more time?
And please
जोर से
don't
बोल
change
रहा
corner files again. रिजल्ट मैनिपुलेट के करने के चक्कर में इसको चेंज मत कर देना, एल्डो सिमुलेटर नहीं चलेगा बिल्कुल भी।
That corner file is you can find the corner file from other location, then computer, then global, then here it is the corner file. Okay, you can copy it and paste it in a CMOS 65 folder.